Recording in progress.
All right. So let's talk about word problems. There's no diagram here, so we're going to draw one. After we draw one, we're going to work it out. Page 10 of the notes. Yeah, it says less than 4 up top, but it's just number 5 on page 10. So here you got a picnic site that measures those dimensions. You want to double the area by adding the same distance x to length and width. Write an equation and then solve for x. So here's the picnic site. What are the dimensions again? 10 by 24. Perfect. However, and what's the area right now, by the way? Very easy, right? But we want area to be 480. We want double the square footage. And how we're going to accomplish that? We're going to accomplish that by adding some distance here and some distance here. So this will be x and this will be x. So that the new area is 480. Does that make sense what I just did? Visually, does that?
Because it's like what's not.
Yeah, so basically it's like you have like these stakes or posts in the ground, and then you're just going to move them further out. You're stretching it both ways until you get double the area. Or it's kind of like if you're remodeling your house, like actually we're thinking about doing that in a couple of years because we're having another kid soon. But like we're probably like knock down one of the walls and blow it out, and maybe blow out the kitchen to the front, so that way we have more square footage, right? So it's kind of the same thing. Like you're trying to expand this region.
What does that say?
But we want.
Oh.
But we want. I just have terrible handwriting.
So that means 10 plus x.
Yes. Yes. Good. You got it. Excellent, Lizzie. Excellent. 10 plus x times 24 plus x has to equal 480. Yes, because this is the new. What? Just to annotate, this is the new area. This is the new. God, I can't draw my W's. That's new width. And that's a new length. Right? So now you gotta solve it, which I know you guys can do, but I'll show you how to solve it. But does that make sense, the setup? Because setup is usually the biggest challenge, I think, for word problems.
Setup is always the biggest challenge.
But if you draw and read carefully, it's not too bad. It's not too bad. Because once you have the drawing, like Lizzie got it right away. She's like, boom, here's the equation. Now let's do it.
So now you just foil this.
Totally. Yes. So let me erase this stuff because now we have our diagram. Our diagram served its purpose. Let me move this up top. Yep, you got to foil first because unfortunately you don't have 0 on the right side, so you can't set each factor equal to 40. It makes no sense. You can't use. You want to use the 0 product property, so you have to have 0 on the other side. So what you have to do is foil.
That's a big.
Then collect. Now, by the way, I will put this in a calculator portion of our assessment because I don't want you to have a calculation error, right? Then collect all terms on one side. All right, so let's do the FOIL right now. If you do it correctly, you should get 240 plus 10x plus 24x plus x squared equals 480. And if you collect everything on one side, probably easier to move that 480 from right to left and rearrange the terms so the leading term comes out first. Yep, minus 240. Now, we could do that little diamond thing. And let's think hard about this one. It's not coming yet. Someone knows, tell me. No, because both have to be
6.
Wait,
what are we trying to add to?
right. I had the third. I got it now.
Wait,
But
why is it negative?
Oh wait, no, I see.
because I've subtracted 480.
No, I see. I see what you're doing.
Oh,
Right.
wait, because that's
Six
gonna be
times
0.
4 is
Oh,
4.
okay, that's not bad.
Okay, I think I heard it. We want to do 6 and 40. We want to do 6 and 40. But one's negative. Now, the reason why 2410 didn't work is that yeah, because one has to be negative, right? Not both negative, right?
Negative 6.
So you get x minus 6 or x plus 40. And by the way, I wouldn't give you a complex word problem. I wouldn't give you a complex equation for word problem because I want to make sure you guys are focused on the development of the equation. Solving is, to me, a bit more trivial because I'll be assessing that elsewhere on a test. It's really more the setup I care about. Now, negative 40 makes no sense. How do you have negative 40 dimension, right? So it's got to be 6. You got to add 6 feet to accomplish your goal.
It's one of those. It's one of those, like, if it makes no sense, but
Right. So you want 6 feet added to each side. That would accomplish our goal. So then, you would just, pull out the, stakes, the fence, or the post.
I said 6 foot, the golden number.
Okay. Question on that one? We're okay?
Greater.
So you have a chance to practice among these problems here. Right. But we're going to discard negative 40 because physically that makes no sense. Right? X equals 6. That's it. Okay. We're good? We're okay? Great. Excellent. Let's keep moving. All right. Let's try another one here. Now, this one's a little strange, but it's okay. And there'll be a problem just like this. I think it's number 21 here, I think, or 20. I can't remember. All right. So this is like a business application. And actually, sometimes this is done in a calculus class. You can use calculus skills to do this problem, but we're using algebra instead. So apparently, if you have 380 people come to a go-kart, say you own a go-kart track, 380 people come by per week, you charge them $35, it seems to be a good business model. Well, you realize, is that going to be the best way to optimize my profit? Can I make more money? Maybe if I drop the price, more people might want to come and join, but you can't drop it too much because then you might lose money also. So you got to find the optimum situation, right? Yes. Well, good. Good.
Or the zenith. I think that's another word for it, right?
Because if you think about it, here's the vertex, the highest point. So here's the goal. Okay, before we get too carried away with the problem, our goal, make a quadratic equation using the given information so that we can locate the vertex, which would represent the maximum money we make. Let me move this down over here. That's our goal. So this is called modeling. You're going to make a quadratic model for the situation, trying to model the situation with an equation.
This is a test question.
It could be. I love this stuff because this is all like data science, data analytics. Like you have a bunch of data, you build a model to predict what could happen. They do this often in finance, healthcare, a lot of industries. This is a fantastic problem. I love this problem. So, but we're algebra 2. We're gonna keep it simple. I'm not gonna make it too complicated. Well, here's what we're gonna do. We have to find the variables. Jamie, go ahead.
You were allowed to have this on the test, right?
Have what? Yes and no. There's some things. Let's chat about that. We'll chat next week about it. Yes, some yes, because some kind of explain a process, which I'm not okay with. But some that are more like memorization, like vertex form or other things. It depends. I'm gonna have that discussion tomorrow with my other colleagues. So I'll let you know by Monday or by email, like, or Schoology update. Anyway, here's the deal. Do we know how many how many people will be coming to, or how much? There's a lot of things I don't know yet. I'm gonna let X. This is tricky. This is the part that's tricky. I'm gonna let X equal the number of $1 reductions, if that makes sense.
Yes.
How many times am I going to reduce the price? Every time I reduce by $1. But how many times do I want to do that? Do I want to do 10 $1 reductions, 20 $1 reductions, 15? I don't know yet. Let Y be the money we collect. Those are not terribly obvious. So you might need to practice another problem like this. I have one in the homework. But if we let X be the number of $1 reductions and Y be money, then the vertex makes sense, right? Because if I could find the if I let Y be money, then the highest Y value is the most money I make, right?
But is it X a reduction? So then it'd be going low.
But more people will come join us. Let's write the model.
Because if more people and it's cheaper.
It's cheaper, more people will come, right? So you got to find that sweet spot. That's what we're gonna do. But we're not gonna do trial and error. We're gonna do algebra, right? We don't do trial and error in this class. We do algebra. So here's how you can write it. So the money we collect will equal the number of people times the price per person. Okay. That makes sense, right? Like if you charge $20 to come to an event, and you have 100 people, you make $2,000, right? But if you drop the price, maybe more people will show up. But if you drop it too much, then you're probably going to be bleeding money, right? So you got to find that sweet spot. But if you like inflation, I hate going out to restaurants because it's so ridiculously expensive. Like $50 for like a sandwich is crazy. But but that's prohibiting. I don't want to go out when things cost too much money either, right? So you want to be mindful of trying to find the right situation. So how I'm going to write it in variable form is this: Y equals, and I'm going to say this. Just go with this for now. I'll explain why I'm doing this in a sec. Oops, I lied. I lied. Here we go. Okay. Work with me here. This is a little tricky. But this is the hardest part of the whole problem. So that's why you guys really focus. Okay. Right now, I do have a hypothetical scenario. If 308 people show up, we charge how much? So if X is 0, if I don't do any reduction, then of course this 20X goes away, and this negative X goes away. I have 380 times 35. If I have no reductions, 308 people show up, we charge $35. That's what happens. Now, if I do one reduction, I have to add 2380, right? How many races do I have now? 400. 400 races. But if I do one reduction, it says that for every reduction, how many more people show up? 20.
Oh,
and what's the price now if you do a reduction? 34. What if I do two reductions? If I do two reductions, 40 more people arrive. 380 plus 20 times 2. And if I drop by $2, it's $33. What if I do 10 reductions? How many more people join me now? Join this business. 200. 380 plus 200. And now how much am I charging if I do 10 reductions? 25. That's why this works. It's a really weird problem. No, it's just thank you, but it's just math. That's all it is. What you have, Patrick, I appreciate that. That's very kind of you. But here's the thing. You have to understand, like, there's a change, right? So these are like, think of these like slope. Right? It's a rate. You multiply the rate by the number of reductions. But because you're gaining racers, you have to add 20. You're dropping the price, you got to do minus X. So that's how that works. For example, what if I had different values here? What if I did, just so you see another scenario, what if I said we get 10 more racers if I do a $2 reduction?
You do 2X.
Then I do 10X and minus 2X. Exactly. Right. That's how I change it. All right. So at this point, can I find, so I want to find the maximum value. Let's find my x-intercepts. So 0 equals 380. No, not necessary. Much easier. Find the x-intercepts.
20 and 1.
No. Negative 19 and 35. When you want x-intercept, y has to be 0.
Do you make y equal? Like,
When you want an x-intercept, you want y to be 0.
and then you-
And you solve for x, exactly. So when y is 0, that means that this has to equal 0, or this has to equal 0. Right?
Oh, so then you just make it.
That's going to tell me my x-intercepts here. So let me redraw this graph because this graph's not terribly accurate. Okay, let me redraw the graph to the right here. Oh, let's go black. What is that? Sorry.
Wait, why is it negative 19?
Okay, so set the
And it can't be a negative.
right. Now, what if you set that equal to 0, Patrick?
Then it's plus 20.
So 20x will equal negative 380. Divide by 20, get negative 19. Right? 0 product property. So negative 19 and 35.
And then on the other side, it's just 35.
Exactly, right. So if I graph this, the graph's gonna look like this, right? So yes, you could have foiled, and I don't know. Actually, it's already fact, and then I think it's just easier to find the x-intercepts this way. Where's gonna be my vertex? Where will the vertex be? What do you guys think?
Negative 19. Oh, in the middle.
In the middle. What's halfway between those guys?
16. Right?
17.
Patrick? 16. It's 16. Don't worry about it. It's 16. Yeah.
Well,
I think it's 16.
Thank you, AJ. AJ's got it. That's what you do. 8 is halfway between 35 and negative 19. 8 is 27 away from 35, and it's also 27 away from negative 19. Symmetry, guys. It's got to be 8. So we have to reduce the price 8 times. 8 times. So you have to do 8 reductions. So now I can get the price. Y equals 380 plus 20 times 8. And then times 35 minus 8. So I got to charge 27 bucks. I'll get more people coming, which is good. But this is the optimal amount, because if I reduce it too much, then I'm making less money, right? So you want to find the optimum amount. And then if you multiply it out, I mean, obviously use a calculator.
That it's like up to positive 8. No, actually, JK, that was not.
No, never mind.
The question, I was thinking 8 was like the value on Y, so the value on X.
It's x, because x was, we defined x as number of reductions.
Yeah.
Right.
Okay.
That was our input.
Positive 30.
Yeah, go ahead. Yeah, totally. Yeah. 380. Hold on, let me just compute it first. And I'll get to your question. Times 27. So you make $14,580. So that's the most money you can make if you do 8 reductions. So now Elizabeth, go ahead. What's your question?
I just don't understand how that's the max.
How's what? Sorry.
How that's the max.
So the things that well, we have the equation first. That's a separate issue that, and we could talk about that. If you're cool, that's great. If you need, but we could talk about it later if we need to. Once you have the equation, you want to find the x-intercepts because it's already factored, right? So I set y equal to 0, which means I made no money, right? But when I solve for x, I got 35 and negative 19. So those are my x-intercepts because it's already factored. Then once I have the x-intercepts, I found the average of those 2 x-intercepts to get the axis of symmetry, which is 8. Now I know, so so basically if I do 8 reductions, that will be the highest points because that's.
Oh, because it's the high. Oh, it's the vertex. Oh.
Yeah, and also it's going to open down because if I were to foil it, the mean term would be negative also.
Okay.
So actually, Elizabeth did kind of ask me a question. I didn't quite, I totally glossed over. How do we know this problem opens down in the first place? It opens down in the first place because if you foil it, you get negative 20x squared, it's a leading term. So that automatically means that's going to open down. So that makes the vertex a high point. So that might answer your question a little better because problems could open up too, and the vertex could be your low point too. Maybe if you're dealing with costs, you want to minimize costs. You don't want to spend as much money. But in this case, we want to collect as much money as possible, right? That's good business. It'd be crazy if you want to give money away. So, yeah. So you'll have a chance to practice that in just a little bit. Let's try another one here. Let's do this one here. So the problem in the homework is on the Golden Gate Bridge, which I think is more beautiful bridge than this one. But still, we'll do this one.
I thought that was the-
It looks like it, or Bay Bridge. All right, so apparently every cable can be modeled with that equation. Actually, if you think about all the cables on the Bay Bridge, or any bridge for that matter, can be modeled using a quadratic equation. If you measure the distance it's off the road, off the platform for the bridge, and kind of measure how far it stretches out, you can actually model the cables as quadratic functions. So apparently they say that each tower rises 307 feet above the roadway, blah, 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 and there's an equation here. Here's what I would do. The distance between the two towers.
Isn't that like going times height?
Kind of.
Isn't just each one like the same amount shorter as the one before? Like it's just like each
mean-
one's gonna be like minus something the last one. Like each one's gonna be what?
I'm not sure I understand your question or your comment.
Like let's say it goes down by 2, but like things each time it's only minus 2 shorter.
Oh, you're talking about these cables. I thought this. No, I'm talking about this right here.
Oh, not
Yeah, no, sorry, those are cables also. I should have been mindful about that. I'm talking about this part here. The part that looks like a parabola. No, I know what you're talking about. And those could be rods or I don't know what they are exactly. Okay, very important. And can we find a way, please? Thanks. Very important. When writing a quadratic function model, it can help place the x, y axes on the diagram. Notice how I put an XY axis on the diagram, right? That way you can easily make an equation, or the equation would make sense to you. So now this equation can fit over here.
Is that equation? Yeah. Oh. So would that mean that,
That equation is what I just traced in blue.
would that mean that the y is 307 equal 1/7?
Hold on a sec. Let me think
Because
about this one here.
307 is like a 1.
So this right here is 1400, and this right here is 27.
what?
Okay, so this is vertex form. So we know this, right? Vertex form, what is A, x minus h squared plus k. So h here is clearly 1400, and k is clearly 27 when I compare this to vertex form. Okay, h is 1400, k is 27. Now, if by putting this diagram on, or putting xy axis on this diagram, right? And I put the origin right here. So at the base of the tower, right? The origin right here. Then it's pretty clear that this has to be 1400. Why would I say that's 1400? Is this the vertex? Is that the low point? Yep. So that has to be at 1400 if that's a 0. This has to be at 1400. And why is that 27? Because it's 27 off the ground or off the platform of the bridge. So that's what you want to do is you want to put XY axis on the diagram. That way you can easily compare this equation to this cable here. With that said, how wide or how long is the distance between the two towers? What do you guys think now? Without doing any math. Really just by doing this like comparisons modeling.
1,000.
2800.
2000, thank you. The answer is 2000. The reason why is that
Really?
exactly right. Because that's at 1400. Therefore, this is at 2800, and this is at 0. So it's not really much to solve. No, exactly.
What happens if you're wrong?
It will be perfect in the middle because we're forcing it to be in the middle. Something like that. I might ask something a little different. You'll see in the homework. By the way, that 307, we didn't even need that. That was useless.
That's just like to trick you.
Sometimes, yes. Sometimes you're given stuff and problems that you have to filter out. And that's noise and the problem we didn't need to have. We filtered it out. So those were good.
For 20, like, it's in vertex form.
Yeah, you were given vertex form. Mhm. Yep.
So 1400 is the X.
It's basically it's how far the low point of the cable is from the base of the tower.
And then, yeah, and then the 27 is how high.
How high it went off the ground.
Okay,
Exactly.
so that's
right.
like that's the vertex.
Yes,
1400.
yes. Yes, exactly. So all I did was I try to connect vertex form to the diagram. That's what I did.
Okay.
In order to make that connection, I had to draw the XY axes on the diagram to make that happen.
And how do you know it's just because like the X was positive and the Y was positive? You just draw the left of it.
Yeah, I mean, great question. Yeah, why not do it over here? You could have, but then I'll be looking at the next cable over. So it's just easier to put it right there.
But if like the X was negative, would you go the other
Well, sure. Then you do it the other way around. Right. All right, let's try another one here. Let's do one with and I'm gonna end after page 12, just so you know. After page 12, I'll stop and you guys can do these problems. So I'll stop after.
Like,
That's
I don't see you guys for 6 days. You guys have time.
that's a lot.
Yeah, you'll have time to do it.
how long do you think it'll take for different ones today?
I don't know. Maybe 45 minutes.
For you, 45 minutes or for us?
Well, for me, probably 8 minutes. I don't know. I don't know. Okay, here we go. So I did undergrad at UC San Diego. Actually, this is a Jeopardy question for you guys. But you go LinkedIn. I did undergrad at UC San Diego. Then I did Stanford about 20-some years ago. I was looking to go. I worked as a semiconductor engineer in my early 20s, and I was going to go back and do that. Then I just decided not to do that because I just didn't like it, and the economy stunk too at the time. Also, right around the time was 9/11, and the country was at war, so there's a lot of just weird stuff happening in the country. So I got an education. I went back and got another degree about a few years ago. So no, from Northwestern. So, but I did it online.
Like, that's like there.
Northwestern. Oh, nice. That's a beautiful campus. If I were to do it over again, I'd probably go away for college. I stayed in California, but yeah.
I use the bathroom.
Go ahead. All right, last problem. All right, so you're kicking a football.
Oh, I think Charlie Brown.
Exactly. It's just perfect because we got like Halloween and Thanksgiving coming up. My kids actually love that Charlie Brown stuff. Like the peanuts. Okay, here's the dude. Here's the football. And he's kicking it. Or is it Jimmy Garoppolo fumbling and getting safety for us?
Since you're good at math, are you good at playing pool?
Playing pool? Not really. I'm actually pretty terrible at pool.
They always talk about like the people that are like good at math.
Geometry, maybe I'd say. No, but you need steady hands. It's
Like calculate everything.
yeah. I'm okay. I play every once in a while for fun, but I'm not really good at pool. Poker, that's another. But that's more probability. I like that stuff better. All right. Anyway, so you kick the football, right? So that's what's happening. So here's the deal. This can be written in intercept form. Actually, it is written in intercept form. You can think of it like this, if it helps. I'm doing a slightly cosmetic thing here. Not a big deal. Same thing. X minus 0, same thing. So because you see an X by itself, you can assume it's part of X minus 0. You can totally assume that. So my X-intercepts are 0 and 46. So if I put an axes right here, the ball starts at 0 and gets 46. That's the path of the football. So how far is it kicked? It's kicked 46 yards. Which is actually very terrible for NFL standards. That's just part A, it's 46 yards. Yeah. So there's not much work you have to do for that one. Now to get the maximum height, that's the y coordinate of the vertex. Well, hold on a sec. What's if you're playing 46, you get 0, obviously. What why 23, Alex? That's good.
Oh, it's gonna be the height. It's gonna be the vertex.
Right. So the vertex is going to represent the height of the football. The y coordinate of the vertex, that was a terrible looking y.
Y coordinate.
The y coordinate of the vertex will be my high point. And I want to know how high it goes, which could matter because if you're trying to clear the uprights, if you're kicking a field goal. Actually, how long was that field goal that won us the game on Friday against the Scatus?
I think
It was pretty short.
I was
Pretty short. Okay.
Okay.
Yeah, high school kickers are always like kind of the. By the way, true story. So we were playing King's Academy before our program started becoming really good at football. Our kicker was one of the students I taught. Actually, stepson of Bill Campbell's building's named after. He cleared the uprights against King's Academy, and he said it was no good. As time expired. Yeah, true story. And we wound up getting a loss, even though the video clearly showed we won the game. So, anyway, when you kick a field goal, you gotta make sure it clears the uprights. You have to have enough height. But I digress. So how am I gonna find the y coordinate of the vertex? What do I do? Yep, and just work it out.
So when you just plug in.
You plug in 23 because 23 is the x coordinate of the vertex. Yeah, and I'll have to use a calculator to work that one because I can't do it in my head.
I got 14.75.
Okay, I believe you.
So that means the maximum height's around like.
14 yards.
Yeah.
Yeah, let me get a calculator and do it for you guys.
Oh, well, that's something.
Actually, it's yards, not feet. It's yards. Yeah, it's probably a high school kicker or maybe a D1 or sorry, D3 college times 23 times 23 again.
I got.
Yeah, 13.754. Yep. Okay, hopefully we're okay there.
Is that height wise?
Yeah, height-wise, yes. Okay, last one. All right. Okay, so we saw this problem already. Yeah, this will be the last one. And I just decided I'm gonna chop off some problems from here. So I'll reduce this homework for you guys in just a little bit. Okay, what are the dimensions of the park? The rectangle, whatever platform, 10 by 12. So my area right now is 120. But we want to triple the area, right? Totally. So, and then you have to add the same distance x to each side.
I don't want it to be 240.
We want it to be 360 actually.
How did you get?
How many yards did that air was it?
You want triple.
What is it? How many yards? How many yards?
13.754. Charlie. 13.754.
You feel like this equations. There's another like that.
Does that make sense what I just did? Let me erase the board. Okay, now you get x squared plus 22x plus 120 x squared plus 22x minus 240. That's not too, wait, hold on. How are we gonna do this one? Hold on a sec. Is that factorable?
Yeah, it is.
It is? What is it?
24, I believe, but I'm pretty sure it's negative 20.
Wait, negative 20. No. Wow, good job, Shannon. Look at that. Yeah, my mental math is not up to par today.
Wait, -8.
Yeah, that totally works. Yeah, good. Good. No, it'll be 8. Because the factor's like this. But you're going to ignore the negative 30 and keep the 8. So the new dimensions will be 18 by 20. $18 by 20 will guarantee we triple the area. Yeah. Do what, sorry? If you do that, then you have 30 by 36. And actually you'll quadruple it. Sorry, you'll increase the area by 9 times. Because areas can be multiplying 2 things. You're multiplying 2 things that both have multiplied by 3. So you're doing 3 and 3, which is a 9-fold increase. You don't want to do that. Right? And plus we're talking about adding that, adding certain distance, not multiplying distances as well. That's good.
Notice, did you notice they're just like times it by just like increase it by both things by 50%.
You could do that, but then you're not adding the same distance to each side.
Yeah.
You're adding different distances. I mean, you could do that, sure.
But it'd be kind of weird and probably take longer than.
Yeah, I mean, yeah. So, okay. So homework. Let me do some updates really fast because I think it's a little too much when I'm signing that. Now, the more I realize it. So for 4-1, I'm gonna chop some stuff off here.
My calculator.
And you don't need it.
I don't need it.
No, you're not.
Or is this from like something?
In my bag.
That's the same one. Let's just do. Well, let me chop these off right here. So just 11. So 4.1. For 4.2, let me chop off 15. So these right here. For 4.3, actually I like all those.
I do.
4.4, I like all those as well. And 4.5, yeah, I only took out 3 problems, sorry. Okay. I like yeah. So anyway, I chopped off 3 problems. So 14 problems. I'll put some schools right now. So we have about 22 minutes for bell rings for school's out. You can make some headway here. It's the same way we've always been working on it.
Oh wait, so for 4.4,
That's what I saw.
Yeah, but I think you guys can handle it.
I get 630 on top.
I have faith in you guys.
I think I lost my homework.
I'll have another one. You don't hold on.
I'll keep looking. I
I
can
get
probably find it.
15. I get 15.
Is it the one that says
That doesn't work.
Yeah, I'll make the
problem sets?
Yeah.
Oh, I haven't.
Yeah, chapter 4 problem set, yeah.
What about?
Okay, let me update schools you also.
I am about to die. This thing is confusing. 7.
We're gonna do numbers.
630. 90,
We're gonna do numbers.
negative 630 on top.